Hi, I'm Bob Henry of Epilog Laser. Thanks for joining us for this Global Spec webinar. We appreciate your time. In previous webinars, we've discussed laser marking and engraving as a cost-effective and efficient technique for producing permanent marks on a variety of metals. Barcodes, serialization, product branding, all can be done very easily with our highly versatile and effective laser systems. The most common type of lasers in the industry are CO2-based machines. The wavelength of light generated with a CO2 laser is perfect for wood, acrylics, plastic, cork, leather, rubber, just about everything except bare metal. Fiber or YAG lasers are great for metal and engineered plastic marking applications. However, the fiber laser wavelength is not used for common organic materials like wood or acrylics. In order to be able to process any type of material, laser operators would need to have two different types of laser systems, a fiber and a CO2. Last year, Epilog introduced our Fusion M2 dual source laser system, which incorporates both CO2 and fiber laser sources in one laser system chassis. This has proven to be a wonderful tool for our customers that want the flexibility to do any material with one machine. In today's webinar, we're going to demonstrate our new Fusion M2 dual source laser system and show you how easy it is to set up jobs, select the right wavelength of light for a given material, and process the job through our unique Job Manager software. With that, let's get started. One of the really nice things about the Fusion M2 laser system is that because it has two lasers in it, we're able to use the CO2 laser source to cut the jigs or the templates to hold tools or components within the laser system. On the table you see we've got some paper product, also foam, wood material, and then acrylic. These are commonly used as templates where the CO2 laser will cut a particular shape. The item then can be nested in those particular materials. Perfectly suitable. Any one of these kind of depends on what you're doing in terms of material and the height of the material, but any one of these products works really well as a template or jig material. Today we're going to be marking on some wrenches here. We're also going to be marking on an individual tool. And then we're going to show you with the dual source how we can mark both or two materials at one time. We're going to be marking on the metal and the wood, and the same here with leather and metal on these flasks. So this is going to be a great demonstration to show you both the CO2 capabilities, the fiber capabilities, and then with some materials, the ability to do engraving or marking with both wavelengths of light on organic type material and a metal material. So let's turn our focus over to the laser now, and we'll get started with some cutting and marking applications. The first marking technique that we're going to demonstrate today is just a single object. Oftentimes our customers have an odd shaped item or just one particular part that they want to mark. Rather than measure over from the 0, position in the upper left corner of the page, our M2 systems have a really unique feature where we can set a new home position. Let me show you how we do that. So I've got just a common hand tool in here. The first thing I'm going to do is hang the focus gauge on here, and I'm going to set the focus, and I do that through the control panel of the laser. So I'm just going to focus this until the material touches on the focus gauge. That looks pretty good there. I'll take the focus gauge off, and then I'll use the jog function to move to the marking location that I want on the part. I'll turn the red diode pointer on. I'm not sure you can see that, but there's a red diode pointer that's shining on the location of the mark. That will represent the center of the marking area. At that point, we're ready to go. So I'm going to lock this home position in place, and then we'll go over to the computer and I'll show you how easy it is to set up this graphic file to run. With this first tool that we're going to mark, we're going to use a common graphic software. CorelDRAW is what a lot of our customers like. Of course, with an Epilog laser, you can use a variety of software programs, Adobe Illustrator, AutoCAD, SolidWorks, Bartender for barcode applications is popular as well. But for today, we're going to use CorelDRAW. So I've typed in some text here, and I'm going to mark that text string onto that part. And again, the center of my graphic will be right where that red dot pointer is shining on the part. So the first thing I do once I've created the graphic is go into our Fusion print driver. This is our print driver, very powerful tool here. I'm going to select a fiber laser. I'm also going to select center engraving. That will tell the laser that we're selecting a new home position within the laser system as opposed to the upper left corner, which serves as the 0, position. I'm going to make this a raster job because I want it to etch nice and deeply into the material. I know for this type of hardened steel I'm going to use a lot of power, so I'm going to use 100% power, and we'll run down to about 20% speed. We're using a 30-watt fiber laser in the M2 today. So we'll go a little bit slower. We offer this machine in 20, 30, or 50 watt fiber options, and on the CO2 side we offer 50, 60, or 75 watt. I'm going to set the frequency low as well. That will give me some good pulsing energy into the metal. So once I've verified all of my parameters here, I'm just going to simply click OK, and then I'll send the job over to the laser. The next step will be to go over to the laser and just simply press the go button. At the laser, we're ready to mark our part. Before we set up the graphic image, we did the focus. We set the lens assembly for the marking at the location that we want. I'm just going to close the door, and then we'll start the marking process. You'll notice that the window on this laser system has a green tint to it. There's an organic dye in this Lexan material that absorbs the fiber wavelength light energy, so there's no potential for that laser beam to escape the cabinet. Of course, safety is very important with any laser system, and this is imperative to have this type of Lexan material on a fiber-based system. We also have glass in here to absorb the CO2 wavelength light energy as well. So with that, we're ready to go. I just simply hit the job button on the control panel of the laser, and then hit the go button to start the marking. That was 10 seconds to mark that part. I'm going to pull it out of the laser here and show you that mark location. You'll see we've got a nice, deep, dark permanent etch into that material. Let's move on to the next material. We're going to set up those wrenches to fit into some foam jig material that we're going to build. The next job we're going to process is creating a jig using the CO2 laser, and then using that jig to hold the tools and then mark those tools with the fiber-based laser. So we've got a piece of standard foam here. This is great. A lot of our customers use this type of foam for toolboxes where they cut a shape for a given tool, and then of course the tool nests right into that location. So the first thing we're going to do is set the jig, the material, up in the upper left corner. The upper left corner is the 0, 0 position in the laser, which corresponds to the upper left corner of the page in the graphic artwork that we set up. I've set this job up to do an autofocus sequence. You'll notice I've got quite a bit of distance between the lens assembly and the material, but we set autofocus in our job manager or our print driver, and then the table will raise to the proper location, and then the cutting will start. So I'm going to close the lid here, and then we're going to go over to the computer and set up this job, and we'll be ready to go. Back at the computer, you can see that we've got a graphic file set up for those 3 wrenches. You can create these images by taking a photograph and then importing that photograph into a graphics program like CorelDRAW, and then simply using a trace tool to define the outline of those. So that's what we've done here. You can see we've got the 3 different sizes in here. So what I'm going to do is to select those objects and then go back to our print driver. I'll go into preferences here, and then I'm going to use the CO2 laser for this job because we want to cut all the way through the foam. I'm not going to use the center engraving feature. This is what we used last time when we marked that single tool. I am going to select autofocus because I want the machine to automatically focus to the right height of that foam material. I'll tell the machine that the vector grid is installed as well. The vector grid is used for any kind of cutting application where you're penetrating through a given material. Below the grid material is some space where the laser beam is dissipated. So in all cutting applications, you would want to use the vector grid. And then the thickness value that we apply here is the thickness of the foam material, and that's 1/2 inch, so 0.5. And then we're going to do the vector cutting portion, and then we're ready to go. So we've got the parameters that we know will work well for this foam, so we click OK, and then OK here, and then the job is sent over to the laser. At the laser, we're ready to cut this foam material. You'll notice when we start the job that the table is going to come up to the proper focal distance, and then the cutting will start. It's kind of hard to see the actual cutting there, but you'll see a little bit of off-gassing of the material coming off. Of course, all laser systems need to be vented to remove the smoke and the vapors and the particulates. So we'll just let the laser run through here and cut these foam pieces, and then we'll install our wrenches for marking. Okay, we've cut those items. Now I'm going to open the lid and we'll just pull out those cut pieces. You see we've got a nice clean cut on all of those. And then we'll drop our wrenches in place. And now we'll set up the next job to mark with the fiber laser. So let's go back to the computer and we'll get that one set up. Back at the computer, you can see that we've got some graphics set up in here. You'll notice that we've got two items that are green in color and one that is red in color. I'm going to explain how we're doing this. Those wrenches are different height off the deck, if you will, and so we program the laser to adjust the focus as it goes from one wrench to the next. These two bottom wrenches are the same height. The top one is a little bit taller, and so we set the focus distances a little bit different for those. So we've got those set up. Let's go to print. We'll go back into the print driver. And here we're going to set up a little bit differently. We're going to select the fiber laser as opposed to CO2. This is the metal marking unit. We're going to autofocus, and we've got the vector grid in. We've got the color mapping tab here. This is really how we tell the laser that we want it to treat those two different types of marks in there. You'll notice we've got a red and a green. We set laser parameters for each of those. So here you see that we've got 20 speed and 100 power, 1 frequency. The thickness, the 0.032, is the height of that wrench off the deck, if you will. You'll notice if we go to the green, that changes just slightly because there's a little difference in the height of those materials, and we need to program those as closely as we can to get more consistent marking between the different components. So once we're done there, we click OK, and then OK here, and the job goes over to the laser. I'll close the lid on the door, and we'll start the marking process. As it goes to the next mark, you'll notice the table height changed just a little bit. That's the programming we did through color mapping to adjust for different focal planes. Okay, this job is done. I'm just going to turn this a little bit, rotate it slightly, and I'll pull one of these tools out and you can see how nicely that marked that material. Always a little bit of dust that comes off, but that's a nice deep permanent etch into that material, and they're all very consistent in mark type and quality. Get it in the right light angle there if you can see it a little better. Okay, let's move on to the next material. Our next job is going to be to mark and engrave on some flasks. We have stainless steel and leather bound flasks we're going to be working with. You can see that we've already got a jig, a template already built in here. This is a really simple, easy template that we built. This is on some real hard cardstock paper. We just cut some squares so this drops in quite nicely. And then we're also going to be marking on the lid, so that'll drop in there just like that. You can see that we're just going to have 3 up here for expediency in the video. We're just going to run 3, but of course you could fill up the entire bed of the laser and run all of those at the same time. So that's our setup for the flask materials. Let's go over to the computer. We'll set up the graphic and we'll send the job over to the laser. At the computer you can see that we've got all these graphics are already set up. You can see these outlines here that we've used. That is the jig or the template for the paper that we cut. The really nice thing about the dual source lasers is that you can cut those items, and then those cut lines serve as the template to hold the parts that you're working on. So I'm going to zoom in a little bit here. Again, we're just doing those first 3 items here. I'll find my zoom tool. I'll zoom in on those just a little bit. Those are the materials that we're going to do right there. You can see everything's all set up. These are individual crests of different families. This is the name that's going to go on the metal part. This is going to go on the leather, and then these are the caps for each individual flask. So again, back to the print driver. We'll go into our Preferences tab. Actually, I'm going to back out here I need to select just the items that I'm going to run for that particular graphic. So I'll capture all of those, and then I'll go to print, and then you can see if I do selection here, it'll just capture those 3 that we're going to actually mark and engrave on today. At the print driver, we're going to use color mapping again to describe what we're doing with this particular graphic. So the red items, you'll notice, are going to be a fiber job. The blue, the cap, is also fiber. If you go to the green material, you see it toggles over to CO2. And then for each of those individual color components, we're specifying a certain speed and power. And again, through color mapping, we can change the focus on the table to allow the material to be in the right focal plane. So here you can see on the green material, we have a 1.1 inch offset. On the blue, the cap, it's a 1/2 inch. So we specified those distances relative to the height of the object in the machine. With that, we're ready to go, so we click OK, and then print. And then we'll go over to the laser and run the job. I'll close the lid on the laser, and then we'll start marking. The fiber laser, the laser that we're using right now on metal, can accomplish a lot of different types of marks on different types of metal. We're using sort of an etch type of mark right now. The fiber laser is really good to produce different colors of marks. We can get a whitish type of mark, a gray type of mark. On titanium materials, we can get different colors to come off of the material during the marking process as well. You notice that focal distance changed. Again, that was through color mapping. I'll also point out that in our color mapping sequence, we have red, green, and blue set up. I can set up color mapping in any order I want. If I wanted to do the cap first, and then the leather, and then the top of the flask, I could do that just by arranging the different color order within the print driver. Okay, our flask project is complete. I'm going to spin this just a little bit, and I'll raise one of these up here and let you take a look at this. This is a great material to show the mixed media or mixed material capabilities of the fiber laser. I'm going to wipe that off just a little bit there. Hopefully you can get the right light angle on that and see the marks on there. Beautiful mark on the metal, also on the leather, and then on the cap as well. Let's move on to the next material. The last application we're going to work on today is another mixed material job here. We've got a wood handle and a metal bottle opener. We've created a jig out of just sheet stock wood here. We've cut the shape of the bottom side of the bottle opener, and that just drops right into place. To get everything lined up, we just put it up into the upper left corner on our vector grid, and we're ready to go. Let's go over to the computer and set up this job, and we'll start marking. Back at the computer, you can see that we've got a template set up for those bottle openers. The size of the page equals the size of the template that we built with that wood. That's 14.5 by 4.5. And then again, these cut lines correspond to the shape of the part. So once you cut these using the CO2 laser, they serve as a great template then for the marking that follows. You'll notice we've got different colors in here. We've got blue, yellow, red, and then magenta color. We've color mapped those different colors mostly for different materials, of course. The blue and the yellow are wood. The magenta and the red are metal, so we color map that. But more importantly, we want this to go as quickly as possible. So we're telling the laser we want to do all the blue first, and then it's going to do the yellow and then it's going to jump over to the magenta, and finally then the red. If we were to do all of these at one time, the lens assembly would travel left and right and just take a lot of time to do that. So this is a significant time savings, also achievable through color mapping. So back to our driver, we go to the print icon and then preferences. We're selecting color mapping here because we've got everything set up. We're going to do color mapping. We're going to autofocus this. You can see that we have different variable speed and power combinations for the different colors. And again, by specifying the blue to go first, it's going to do the blue, and then it's going to jump to the yellow, the magenta, and then the red. So we've got everything set up here. We click OK, and then we print the job over to the laser. Back at the laser, we've got our material position in place. We've sent the graphic file over. Let's just close the door, and we'll start the engraving and marking process. So recall we color mapped this, so the blue will be done first. That'll be the two wooden objects on the left-hand side. And then it'll jump over to the wood objects on the right side, and then we'll start the marking on the metal components. Again, this is all done in one job setup using the two different laser sources, both CO2 and fiber, in the Fusion M2 machine. With the CO2 laser almost done with the wood marking, you'll notice that the table is going to come up to get into the correct focal plane for the fiber laser to mark the metal components. With that beep tone, we know our job is done. So again, we've just marked some wood and metal components with the dual source laser machine. Got a really nice deep engraving into the wood, as well a really nice dark permanent mark onto the metal component. All right, we finished our marking and engraving process. A little summary for you. Again, on the bottle openers, we use the fiber and the CO2 laser together in the Fusion M2 machine to do both the wood and the metal marking. We cut the jig for this particular material with the CO2 laser. The tool, we used our unique relocatable home position to put the part anywhere we wanted on the table, locate the mark where we wanted it, and mark this metal component using the fiber laser in the M2. We also showed the foam cutting to create a jig or template for these tools. So we use the CO2 laser in the M2 to cut the material. We use that same graphic file to act as our template for locating the marks that go on the tools, and then we use the fiber laser to mark those. And lastly, we used the CO2 laser to cut the jig of paper for the flask materials, and then through the color mapping function and the print driver, we set up different speed and power parameters for the leather relative to the metal components, and of course selecting CO2 versus fiber laser. We hope our demonstration provided you with some good information about laser capabilities. With the Epilog Fusion M2 laser systems, our customers will have one machine that will mark, engrave, and cut virtually any material. We'd be happy to discuss your applications in more detail. Look us up online at epiloglaser.com or give us a call. Thanks again for joining us today. Have a great afternoon.